All right, what's up? It's Hutch here, and we're on Module 9, not Module 9 Probability Practice Test. Let's see how you did with everything. Okay, so Lesson 1 and 2 are all about likelihood of events. We know that it's between 0% chance and 100% chance, or between 0 and 1, if we're looking at the decimal form. So let's take a look at this. Always focus on what the outcome is that you're paying attention to, which is landing on a hamster. Well, since there's only one hamster out of all this, it would be unlikely to land on a hamster. Remember, equally likely is a 50% chance, and so anything above or below that would be one of those other options. All right, what is the likelihood of landing on an animal? Well, they're all animals, so that would be a certain 100% chance of that happening. Okay. All right. Number 3 and 4, we're looking at relative frequencies and using those relative frequencies to make predictions if necessary. So number 3 says a spinner with 4 equal sized sections of blue, green, yellow, and red is spun 10 times. So just letting you know you have a 4-section spinner. And here's what happens when we carry out the experiment. We land on blue 41 times, green 10 times, yellow 8 times, and red 68 times. And then it says, what is the relative frequency of landing on a blue? It also says round to the nearest tenth, so be aware of that as well. All right, so when we're talking about just what is relative frequency, we don't need to write that probability notation. We just write the fraction decimal percent, but we do need to round to the nearest tenth. Okay. All right. So relative frequency of landing on blue, it says blue is 41. Okay. So it's 41 out of how many times did we run the experiment? Okay. And so here we go. Let's go ahead and add up all the times we actually spun the spinner. So 41 plus 10 plus 8 plus 68 is 127 times that we spun it. Okay, so there we go. All right, and let's go ahead and turn this into a decimal. So we have 41 divided by 127. And we get this long decimal. So this is where you have to be careful with your rounding. So 0.3228, and I'm going to stop after 4 spots. So cutting it at the 8, because of the 3 to the right, it stays an 8. And then multiply by 100, and we have 32 point, and if we're cutting it here in the 10th spot now, we do 0.3%, okay? Just got to be really careful about that, okay? All right, so there's the relative frequency is 32.3%. All right, let's head over to number 4. If the cafeteria sold 85 pretzels this month, how many would you predict them to sell if they sold 1,200 snack bags next month? Okay, so we're focusing on the 85 pretzels, okay? But we need to create your base ratio here of 85 pretzels out of how many snack bags sold this month. So we have 250 plus 125 plus 340 plus 85. So that's how many snack bags we sold this month, is 800 snack bags. And when we want to predict, we create a proportion because we want to predict, well, how many of those pretzels would there be if we sold 1,200 snack bags? So you can cross multiply or you can find the multiplier. Okay, I'm just going to find the multiplier. I wonder 800 times what gets 1,200. So we'll do 1,200 divided by 800. And you can see the multiplier is 1.5. So I'm going to multiply by 1.5 over 1.5, and 1.5 times 85 gets us 127.5 pretzels. Okay. You obviously can't have half of pretzels, so we would go ahead and round to 128 pretzels. Okay. So I would predict to sell 128 pretzels. Okay. All right, and there you go. If you did want to cross multiply, that would, let me try to erase this for you so you can see if you wanted. Cross multiplying would look like this. 800x equals 1200 times 85. And then we would divide both sides by 800 to isolate the variable. And we'd end up with, divided by 800, the same thing, 127.5. Okay. All right. So there's both options for you. All right. Let's head to 5 and 6. You can see that we're finding the complement. Okay. And then we're also looking at another spinner problem. So number 5, the table shows the lengths of times for rides at a fair. Cuddy will choose a ride at random and wants to find the probability of choosing a ride. So it said probability, which means we need this probability notation of choosing a ride that lasts more than 120. Okay. But they're actually asking what's the probability of the complement. And we know complement means the opposite of that. So instead of more than 120, I actually want to find not more than 120. So right now I'm going to write that. So not more than 120 seconds. Okay, so let's go ahead and highlight all the things that are not more. Okay, or they're not more than 120, which includes 120. Okay, so because 120 is not more than 120, it's exactly 120. So that's the one tricky one you got to be careful with there. Okay, so less than or equal to 120. So we have that one, and that is it. Okay, so the probability of choosing a ride is 2 out of 3, 4, 5. So 2 out of 5 chance. Okay, what is that as a decimal? Well, 2 divided by 5 is 0.4, which if we swoop over or multiply by 100 is 40% chance. Okay, all right, so on to number 6. A pet store is having a prize giveaway. The spinner shows the types of toys a customer can win. If the spinner is spun 540 times, about how many bird or cat, so we're focusing on bird or cat, are expected to be given away. It also said, since it said bird or cat, we're going to include both of those. So you just have to count them up. So we have 1, 2, 3, 4, 5, 6, 7 out of 8, 9, 10. So counting up that correctly is really important. So we have 7 out of 10 that are bird or cat. And instead of out of 10, we want to predict what happens if it's 540 times. Okay. So same thing. We can find our multiplier or we can cross multiply. Okay. So I'm going to go ahead and try to find the multiplier. 540 divided by 10. And we obviously have 54, nice easy multiplier, times 54 over 54. And 54 times 7 is 378. If I cross multiplied, I would have 10x equals 540 times 7 is 3,780. And then divided by 10, we would have x equals 378 as well. Okay. All right. So let's go ahead and answer the questions. If the spinner's spun 540 times, about how many bird or cat toys are expected? So you can expect about 378 bird or cat toys. Okay. And there we go. All right. Let's head to the back. We have number 7. This is analyzing which graph goes to which experiment. So we have two experiments are conducted, and their results are recorded in frequency bar graphs. So remember, frequency bar graphs share the probability or the relative, or they don't. Relative frequency ones do. If it just says frequency, they're telling you the actual amount of numbers that happened. Which graph goes to which experiment? So we have a 6-sided number cube is rolled 50 times, and then we have a 6-section spinner is run, but section 1 and 2 are smaller than sections 3, 4, 5, and 6, which are equal in size. So remember, your tip for this was look for the extremes. So the extremes are that section 1 and 2 are smaller, and I can see right here section 1 and 2 are smaller. So I'm guessing this one is student 2, and 6-sided number cubes are all pretty even, which so is this data, and so this would be student 1. Okay, all right, that's it for those. Number 8 and 9. This is our tree table or tree diagrams, and what is the probability when we're talking about compound events, meaning two events happening that are independent of each other or dependent of each other. So number 8, the sub shop sells bread in 4 types: white, rye, seasoned, and cheddar. Okay, so I'm going to highlight that. And they offer 3 types of cheese: American, Swiss, and mozzarella. Make a table or tree diagram to show all the possible outcomes. This is the moan and groan, like, ugh, because you need to list all the outcomes. So I prefer a tree diagram. You can also do the table. Okay, I'm just going to do the tree diagram for this one. Okay, so we have white, we have rye, and we have seasoned. And so those are my first. And we have cheddar, so hold on. White, rye, seasoned, and cheddar. And then we have 3 options that branch off of those. So we just go like this. And we have American, Swiss, mozzarella, ASM, ASM, ASM. Okay, and then you do have to actually share the results. So I can have WA, WS, WM, RA, RS, RM, SA, SS, SM, CA, CS, CM. Those are all the possible outcomes right there, and leaving them in that form was just fine. If you were to do a table, okay, it would look like this, and it would go across this way, okay, and you would list white, rye, seasoned, cheddar, and you would list American, Swiss, mozzarella, and then you would fill out the inside, WA, WS, WM. So actually, maybe I do like the table better. This is a little bit quicker and easier in this case, maybe in a lot of cases. So, but remember, this only works well if you have just 2 events, which we do. If you have 3, you need to be doing the tree. All right, so there's 2 different options there. All right, number 9, a number from 0 to 9 is randomly selected, and then a letter A to D is randomly selected. What is the probability of pulling a 3 and a consonant? So I have to write the probability formula, or probability notation, okay, of pulling a 3 and, okay, or instead of and, you could use that symbol, consonant, either or. Okay, equals. All right, now you could do a tree or table to see all the outcomes and then look and find that probability, or you can do the math work of the probability formula that I showed you, and that is the probability of A times the probability of B. Okay, so the probability of A happening, okay, so we have pulling a 3 and a consonant. So from 0 to 9, okay, you have to think through that a little bit here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the chance of pulling a 3 is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's something a little bit tricky that you have to be aware of. So the chance is 1 out of 10 times, and then what's the probability of getting a consonant? So we have A, B, C, D, and the consonants are 1, 2, and 3. So 3 out of 4 chance. Okay, and so if I multiply that straight across, we have a 3/40 chance. So 3 out of 40. And then 3 divided by 40 as a decimal is 0.075. And swoop, swoop, that's a 7.5% chance of happening. Okay, so not very good chance. Okay, all right, so that's the work and the answer that you need to have for that one. Okay, all right, last two is your simulations. So suppose there is a 3/4 chance of rain in the month of April. So there's my base probability. Draw a spinner that you could use to run this simulation. So obviously I can easily draw a spinner and make it out of 4. Okay, and I can make this be R, R, and R, and this can be N for no rain, something like that. Okay, so a 3/4 chance of rain in the month of April, and I could use that spinner to then run the simulation. Okay, all right, so we actually ran the simulation, determined whether it'll rain or not rain next weekend. Based on the prior data, what is the experimental probability, so I need the probability notation, of having rain on both days? So this is where you would go through and highlight. So I have rain, rain, and rain. Okay. So what is the probability of having rain? Well, we need to write this first. So rain on both days equals a 3 out of 10 chance. 3/10 is 0.3, swoop, swoop, 30%. And there we go. Okay. All right. So that is your practice test. If you need help, talk to me before the test. Good luck.